This is Dr. Rodriguez for Psych 101. This is Chapter 2 and Part C. Let's talk a little bit more about correlational studies and experimental studies. So remember, correlational studies are all about relationships. How are two variables related? And experimental studies are all about the cause. Does one variable cause something in the other variable, cause a change in the other variable? So correlational is relationship, experimental is cause. Let's talk a little bit more about correlational first. All right, so correlational studies, what you do is you go out and you get number data, maybe GPA and age. You get this number data through surveys or maybe interviews or records or physical or psychological measures. So you get this number data and you plot it on a graph, all right? You plot it on a graph, and I'm going to show you how to do that with Excel for the data that we got in class. Remember the GPA data? I'm going to show you how to plot that information and then get a plot graph, and then you put a trend line on. And these graphs don't show the trend line, but you can kind of see how there's a line here, right? So if you see a line that's kind of going up, then that means it's a positive correlation. That means that when you hear positive correlation, it means that both variables are doing the same thing. As one variable goes up, the other goes up. As one goes down, the other goes down, all right? So this graph over here has all these little dots. Each dot is one person's information. And you plot these all and you can see a trend, you can see a pattern. And this one shows a positive correlation. That is one thing. As one variable goes up, the other goes up. Now this one over here, this one shows a negative correlation. The line is going more towards this. It's starting up and it's going down. So that shows a negative correlation. That means that the two variables are doing different things. As one variable is going up, the other is going down. Or as one is going down, the other is going up. So as hours of sleep goes up, tiredness goes down. Or as the hours of sleep goes down, tiredness goes up. They're doing two opposite things. So that's a negative correlation. Now, if you put these little dots on the data on the graph and it's all over the place, you don't really see a line, that means that there's no correlation. These two things are not related. All right, and so I'm going to show you how to plot that with our information. But for now, just know that you get the data, the number data, you put it on a graph, you do a trend line in different calculations. The calculation will give you a correlational coefficiency. The correlational coefficiency looks like this. R equals some number. And that number tells you the direction and the strength of the relationship between two variables. How closely related are these variables? All right. So here's the correlational coefficiency. Now, if you see the plus or negative is going to tell you if it's a positive or a negative relationship, a positive or a negative correlation. So this graph right here would have plus and then some number because it's a positive correlation. Both variables are increasing or decreasing. If you see a negative like this one, it's going to look more like this. It means that the variables are doing two different things. One's going up and one's going down. Now, the number of the correlational coefficiency tells you how strong the relationship is. Now, when you're figuring out how strong the relationship is, don't pay attention to the plus or minus, okay? It's not algebra, all right? So just cover up that plus or minus and just look at the number. Okay, so just look at the number, and is that number close to 1 or not close to 1? This one is close to 1, isn't it? It's 0.89, so that means it's a strong relationship. Even though it has that negative, we cover that up when we're just looking at the strength. And we just look at the number and see how close to 1 it is. So this correlational coefficiency says negative 0.89. So when I look at that, I can tell it's a negative correlation, and it's a strong correlation because it's close to 1. So the plus or minus tells you the direction of the relationship, if the variables are doing the same thing or not. And the actual number tells you the strength is the number close to 1. And when you're figuring out the strength, remember, don't pay attention to the plus or the minus here. So let's look at this one. R equals plus 0.89. 0.89. That means that there's a positive, right? Positive relationship that as one variable goes up, the other goes up, or as one goes down, the other goes down. It means they're doing the same thing. So it's a positive relationship, and it's a strong one, isn't it? Because it's 0.89. That's close to 1. So how about this one? R equals negative 0.89. That means it's a negative correlation. The variables are doing different things. One's going up, one's going down. And it is a strong correlation. It's a strong relationship because it's close to 0.89. All right. So you need to remember that with correlation, it is not causation. It just shows the relationship. It just shows that, hey, as one thing goes up, the other thing goes up, or it goes down. It just tells you how these two variables are related. It does not mean causation. Let me give you an example of that. So if you were to go out and look at the number of ice cream cones being sold and the number of murders happening, what you're going to see if you plot this information is that as ice cream sales goes up, so too do murders. As murders go up, ice cream sales goes up. Now, this information is just telling you that these two variables are related in some way, okay? It doesn't mean that ice cream causes murders or that murders cause people to eat ice cream. That's not what it says. It just says that these two things happen to be related, okay? And it's not a cause, it's just a relationship, because there could be a third variable or confounding variable that could explain the relationship, like ice cream and murders. What could be the confounding variable is summertime or hot weather. During hot weather, more people eat ice cream, as well as during hot weather or during the summer, people are out more. They're out longer in the evening. There's more daylight, so people are just out more and interacting with others. Therefore, murders are more likely to happen because more people are just out and about and interacting. So ice cream does not cause murders, and murders do not cause ice cream eating. All right, it just means that these two things are related and there could be a third variable involved.